Yeah, and I have a whole list of cool sci-fi books if you're interested in them. I can give you them after class, but let's leave it at 2 titles for for.
The game book is free.
Yeah, that's what I said. Didn't I say that?
You didn't know for sure.
Yeah, you know, it's confirmation.
Oh, I gotcha. Yeah, I actually did know for sure. Yeah, so I don't know. Maybe I misrepresented it, but I did know that for sure. Well, I don't read them. I do audiobooks. I don't listen to music. Music makes me aggravated. It's a thing. I don't know. All right, so near the end last time we were kind of comparing Java and C#, and I'm going to gloss over this just a little bit just so we can kind of bump ahead. But Microsoft stole Java, lawsuit, blah, blah, blah. Ultimately, Microsoft lost, had to come up with their own language. That was C#. I was actually there at the ACM conference in University of Illinois, Urbana-Champaign. I want to say it was in the year 2000 or 2001 when Microsoft, might have been 99, I don't know, somewhere in that ballpark, when Microsoft announced C# for the first time. And when you go to these conferences, you always go to the Microsoft because they give away the best free crap, right? The other guys are giving away like little bouncy balls and stuff like that. Well, Microsoft was giving away sealed boxes of Visual Studio Professional 6.0, which is like $500 or $600 software for free. And all of us had already pirated it, so we went and sold it on eBay. Now, that was in a former life, people. I encourage you not to do that. But also a true story. But in any case, I'm sitting there, and so this is 17 years ago-ish, something like that. And I'm sitting there, and I'm listening to this guy describe C#. And I had been writing Java since Java had come out. So I, was very up on Java at the time. And I basically listened to this dude just describe Java as he's describing C#. Well, as we're kind of painting this picture and kind of in support of what I've been saying, all of these languages came from C. So just because something is very similar to the language that came before it, that's kind of par for the course, right? You're going to take most of the stuff that worked and then replace a couple of things that maybe didn't work. So at the end of class last time, we were looking at the model by which Java and C# ultimately run on a CPU. So Java, we write our high-level Java source code. And remember, Java we advertise as being write once, run anywhere, the platform-independent thing. And their original goal for that was to, let's say, appease the Mac gamers. But then we kind of talked about, since it's partially interpreted, games aren't really its thing. Outside of, like party games like Angry Birds or something like that. You're not going to be playing Battlefield or, big time, games like that in Java. They're not going to be running in Java. It's just a performance problem. But you write your code, you run it through the compiler, which translates it from a high-level language into a low-level language. For Java, that low-level language is called Java bytecode. For C#, it's called missile code, Microsoft Intermediate Language. Same diff. All right, they're just low-level languages. All right. Those guys are then run through this an architecture. So for Java, it's run through a program that runs on the computer. So this is an interpreted step. So the Java virtual machine takes Java bytecode while the program is running and in real time converts it into the equivalent. So remember, we're dealing with a low-level language. It's a one-to-one relationship, right? So every line of code here translates into one line of code for the CPU. So we have one line of code to probably one line of code here. Sometimes you might have some instructions that split, but generally speaking, we're not dealing with one to many when we do this conversion. So one line of code to one line of code that runs on the CPU. But that's happening while the program runs. The .NET component architecture, on the surface, we can say, well, this guy is the same as a Java virtual machine. The difference is that the .NET component architecture is not a runtime environment. Okay, it's a prior to runtime environment. So what happens here is this missile code, the very first time you double click on the icon for your C# program, this missile code gets converted into native assembly code. This is almost like a compilation step, with the difference being that compilers are typically thought to convert high-level languages to low-level languages. In this case, we're converting low-level to low-level, okay? But this happens one time ever. So when we first double-click on it, the missile code gets translated into native assembly code, so the first time you run the application, it takes a little bit longer for it to launch, all right? But then you're dealing with, from that point forward, native code for the CPU. You can do games for that, right? So at that point, it's like, well, we're not interpreting this. It's not running through the JVM every single time you run the application. So every single time you double click on a Java application, all of that crap is happening. Every single time you double click on a C# application, minus the very first time, only that stuff is happening, which is the equivalent to C and C++. Okay, so that's performance. Now, Microsoft would argue, so we kind of just answered the question, what's the difference? So if we say C# here, Microsoft, in Microsoft fashion, would argue that C# is platform independent, because that was a buzzword back then, right? It was a buzzword. That was what Java had going for it, even though people, the average consumer doesn't think about things at the level of performance like that, right? Us in here, and this is what we've been talking about this last week, is kind of becoming educated as technological consumers. We know better than the average person who stumbles into Best Buy or something like that, or we should, right? Many of us kind of saw that we don't necessarily know as much as maybe we thought we knew, but we should know better. That's part of why we're going to college, to be a computer science person. We should kind of have a grip on the technology side of things. Maybe when it comes to chemistry, or the pharmacy stuff, we don't know one pill from another, but computer science stuff, we should kind of have a grasp on. So Microsoft was taking advantage of this and saying, hey, C#'s platform independent, just like Java. So why not come over to Microsoft, use our really cool development tool, Visual Studio, and use C# and have all the perks of Java. And we kind of see from this thing here that Java and C# look very, very, very similar, right? But we've kind of seen the difference here. But we have some questions about this guy. So Microsoft would say that C# is platform independent. It can run on any platform at all, as long as it has the .NET component architecture, which is the same thing as saying it'll run on any platform as long as it's Windows. Okay? It'll run on any machine, as long as you're running Windows on it. All right, so now, having said that, Microsoft is starting to look at porting the .NET component architecture to the Mac. Now, there is a project, anybody know the project for Mac and Linux that attempts to mimic the .NET component architecture? Because this was a closed source. .NET was a closed source architecture, so you couldn't just take it and port it to something. You had to basically investigate how .NET seemed to work and then try to mimic it over here, kind of like Java Virtual Machine, where you have two virtual machines. They're not necessarily implemented identically, but they're functionally equivalent, right? So anybody know what that project's called on Linux and Mac?
Is it Mono?
Mono. Yep, Mono. The Mono project. So Mono project lets you use effectively an IDE known as Eclipse, and I'll talk about IDEs at some point, but to write C# code for the Mac or for Linux, and they have I don't believe it's currently a full implementation of .NET, but I'm pulling a number out of the sky here, but like a 90% implementation of .NET, something like that. So you can write a lot of C# stuff for the Mac or Windows, or the Mac or Linux. Reality being, though, if you're writing C# code today, you're working in a Microsoft environment. Similar to that premise that people who are living in a Mac ecosystem. So I run a Mac, I have an iPhone, I have an Apple TV at home. All those things kind of work flawless. I have an Apple Watch. These things all connect with each other, and they just work because they're all from the same ecosystem, right? Well, if I went and got an Android phone, then my watch becomes mostly useless, right? Okay, so it's about the ecosystem. Well, Microsoft is similar to Apple in that regard. If you're a software developer and you're working within the Microsoft ecosystem, you're using Visual Studio, you're probably using C# as like their flagship programming language, let's say. Unless you're a game programmer, then you might be using Visual C++, but let's just say C#. You'd be using the same tool. That's one of the nice things about .NET, kind of almost a, I don't know how important of a feature this is in .NET, but from a trivia perspective, it's actually kind of an interesting feature. I can replace C# source here with any of the .NET languages. So I can write Visual Basic, I can write C++, I can write, well, I can technically write C since it's in C++. I can write C#. There's now a Pascal based language that's in there. It used to be called Fox Pro. So I can pick any of the .NET languages. And I can write any part of my project in it. So I can write one screen in my application in C#. I can write another one in Visual Basic. And they can all work together because they ultimately all compile down to missile code. So kind of an interesting trivia thing, but the reality is I don't know how often people would kind of jump around in languages. Maybe in the early days of C#, somebody maybe would have written some networking component of their application, maybe using Visual Basic, since some of its networking stuff was pretty easy to work with, where C# was modeled on a more complex language where you maybe had more power with the networking stuff to do more things, but for trivial tasks, when you're sending stuff across the internet, it might have been more difficult to work with. So maybe in the early days, you may have found some benefit in being able to pick and choose which of the .NET languages you wanted to use when you're writing a certain portion of your project. But realistically, today you're going to be using C# for everything. But it doesn't just end with that. So you're maybe picking C# as your programming language, your development environment, so kind of your word processor, let's say, for writing your code is going to be a product called Visual Studio, which is Microsoft's write code word processor. Your database is going to be SQL Server, which is a Microsoft product, because all those things just work seamlessly. There's no like crazy connection string to get your code talking to some database in the cloud here. When you're using Visual Studio, you just click a couple of buttons and now those guys are talking. Okay, it just happens automatically. If you want to do cloud computing stuff, you're going to be using Microsoft's cloud, which is called Azure. Okay, so as long as you're living inside of the Microsoft ecosystem, everything works flawlessly, or everything, well, maybe not necessarily flawlessly, but should be very compatible with each other. So typically, and this is part of why we talk about all these different languages, is typically you're going to pick the right tool for the job. It's not fair to say that one of these languages is necessarily better than another one. When we go back to our picture here, that kind of shows our evolution of our languages. We see Java and C# are pretty, similar in terms of, time frame with each other. I would call these two languages two of our big three today. Okay, so I have this, it's kind of my phrase, I guess. I say big three, and this is on the native side of things. So we'd have Java, we'd have C# or the .NET languages, we could say. And then historically, I would have said Objective-C, and we'll add that to the chart here quickly in a second. But now that's been replaced with, anybody know what Apple's newest language is? Swift. So this would be the new upgrade. Let's upgrade to this guy. All right. And generally speaking, when we're saying let's pick the right tool for the job, Java is going to be for cross-platform business apps. And then I'm also going to throw in here the idea of applets. So Java applications that launch out of web pages. I think I mentioned that last time, where kind of a big market for it is in the stock investing world, where you pay that $99 and, some professional level application launches right out of the web page. That's all Java tech. All right. C#, that's going to be the right tool for the job when you're writing Windows crap. Okay. All day long. If you're writing something that's only going to run on Windows, you're running native Windows stuff, you're doing yourself a disservice by using Java. Java's tools, and this has been a weakness of Java for years. All the different Java technologies, if you go to java.sun.com, that's the site I always go to, which then maps you over to Oracle, but my knowledge for that is 20 years old. So that's the site I always go to. You'll see on the right-hand side, there's like 40 different Java technologies. And the problem that they always ran into is they weren't integrated into like a single product. You never had that Visual Studio product for the Java world. They did have a product called NetBeans that came out of Sun Microsystems, but it still was really just one or two Java technologies. You didn't have all the extra stuff. So it was a very disjointed ecosystem where if you're doing Windows stuff only, it would not be in your best interest to use Java. I mean, you're going to use the .NET stuff because it's made for exactly what you're targeting. And a big difference here is we could say with Java, GUIs suck. Graphical user interfaces, writing your interfaces for your application. In C#, GUIs rock. Everything's drag and drop. You put a button on the screen. You want that button to do something. You double click on the button. It opens up the code for the button. You write your code. That's what the button does. Okay, very simple. Makes a lot of sense. The Objective-C in Swift world, the equivalent of Visual Studio is a product called Xcode. And we put that in that same category with the .NET stuff. So, you know, if you're running, so Xcode is the tool. That's the Visual Studio for the Mac. And it has all the same perks. You know, if you're running Apple stuff all plugged together, it all works, you know, works nicely together. Although it is important to point out, though, that Apple does not have their own database. So you don't have that simple plugin. Most technologies for making your, you know, iPhone apps or whatever talk to the cloud are fairly easy to drop in, but I think you'd still give the nod to the Microsoft side of things because it's all completely integrated. Apple does not have their own cloud computing platform, and we'll talk about what all that means, but you know, they don't have the equivalent of Microsoft Azure. So we could say that from a development, you know, ecosystem, Microsoft's ecosystem is more complete. Make sense? So if you're living in the Microsoft world, you're living in Visual Studio. You would be just stupid not to pick that as your tool. That's the right tool for the job. If you're living in the Mac world, Xcode your answer because or you're writing it in Java. Can't run Visual Studio on the Mac unless you dual boot Windows, and now you're writing stuff for Windows, not for the Mac. So we would say the other thing for Java, and this is a big thing that's really kept Java relevant, is Android apps. So all Android apps are written in Java. Okay. C# is the Windows stuff, Objective-C, this is the Mac stuff. So, you know, we have a very segregated ecosystem for what's the right tool for the job on the native side of things. Native meaning Mac, PC, and then runs on everything, all the native platforms. All right, so none of these are necessarily better or worse in a clear-cut way than the other until you add in the context of what am I targeting? What platform am I targeting? Make some sense? Okay. Now, what I'm going to do here is I'll go ahead and throw the guy up, and actually and I'm going to really gloss over this little story. We did talk about the Steve Jobs getting fired from Apple stuff, right? We did. Oh my gosh, I can't gloss over that too much. All right, we'll try to go fast.
Yeah, then he started his own company.
Yep. So.
Then they bring him back.
Yep. So I mean, it's an important story for us. So let's get through it. So in 1983, when C++ was adopted, this was our move from procedural languages to object-oriented languages. Microsoft jumped on the C++ bandwagon. Well, Apple, Microsoft, enemies, right? So they're not going to jump on the same technology because they don't want to be kind of reliant on each other. So Apple backed kind of a competitor to C++ called Objective-C. So Objective-C, I often will actually use it as a teaching tool, and at some point you'll see it. So I'm not going to go too far into it, but it does look, if you look at C and C++ and Java and C# code, they all look very, very, very similar. If you look at Objective-C code, it does not, I mean, once you get into it and you get past the syntax, the visual difference, it is the same. But the default code in Objective-C at a glance looks different because in all these other languages here on the left, it's always something dot something else. So just to kind of give you the quick glance at it, you know, it might be in Java, for instance, to write something out, we'd say system.out.println hello, something like that. The equivalent in Objective-C would be system out println hello, like that. Okay, a lot of square bracket stuff. It uses, instead of dot notation, it uses a syntax called message passing. So we are passing this message right here to this dude called system. We are passing this message right here to this dude called out, so on and so forth. At the end of the day, the same stuff's happening. All right, but at a glance, you can see that this might look more intimidating to somebody who's been living over in this world for a while. And then all of a sudden is going to jump over to the Objective-C side of things, which a lot of people did. You know, when the iPhone came out and people started writing software for iOS software is written in Objective-C. So you had a lot of people pouring over from the Java world, learning Objective-C and having to deal with kind of an initial visual shock. Where before, when you were going from C++ to Java to C#, I mean, the move from Java to C# is trivial. These languages look nearly identical. Couple of words here, like the hello world in Java. If you copy and paste the Java hello world program into C#, you get like 3 errors. Okay, you fix a couple of things, and now you got a working C# program. You know, they're identical. And we're talking about things like the word string in Java is capitalized, the word string in C# is not. You know, stuff like that. You know, little tiny details. So in any case, with Objective-C, Apple went against the Microsoft thing to keep a split because you had these guys in competition with each other. And Objective-C was still used today until very, 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 very recently. Just a couple years ago, when they came out with Swift. All right, and with Swift, so let's put a date on this. Let's go 2015. It's probably right. 14? Okay. Was that when it was announced or when it was first introduced into Xcode?
I seem to remember the documentation first going up.
Okay, fair enough. I mean, this is ballpark. Recent, right? Much more recent than these guys. Okay, I mean, we're talking 20 years newer. All right, so, you know, we're going to call this guy our most modern programming language out of all these guys. But I'm gonna put a question mark over here just for now because we're gonna answer this this question in a bit. Hopefully even today, if I can zip through some of this stuff. Understand that Swift is not the upgrade to Objective-C. Okay, I've been writing iPhone stuff since the iOS stuff first came out. I probably still prefer Objective-C over Swift, but I write all my stuff in Swift now because that's what, you know, it's what everybody does. You want to use the newest tools and stuff like that, but you could choose to still use Objective-C. I guarantee you, if you were already drinking the Apple Kool-Aid, these folks were not complaining. Nobody was saying, oh, Objective-C is so old. People loved Objective-C. It was great. Okay? They didn't care because, you know, this is job security. If you knew Objective-C, you're dealing with this kind of this archaic, still sticking around from the early 80s technology, and, you know, you're in this elitist group of the Mac people, and, you know, oh, Windows people are evil and all this stuff. You know, you had job security because a very tiny percentage of developers were Objective-C developers. Now a significantly larger percentage of people are Objective-C, were Objective-C developers because of iPhone, right? And that came out of, that wasn't necessarily a love for Apple. That was a love of dollars. If you're, even today, I mean, whether you're an Android fan or an iOS fan, if you want to make money making mobile apps, you write software for iOS. That's where the dollars are. You can make money on Android, but I think the numbers come out to the same application on Android versus iOS. iOS kind of triples, I think about triples the revenue, even though they have the same underlying revenue model. And it just comes down to the number of people who have devices, because you look at the number of Android devices, it's greater than the number of iOS devices, but you have to look at latest software release, and the number of people who are running the latest iOS software is far, 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 far greater than the number of people that are running even the last 2 versions of Android. Just because you have a zillion different Android devices that are all running different flavors of, and literally with Android it is flavors, right? They're all after desserts, ice cream sandwich and all that stuff. So it's just an interesting competition. But the point is that, and certainly since Apple's App Store came out before Android's App Store, if you're a developer and you want to start making dollars, you learn Objective-C and you start putting your software on iPhone, right? And a lot of people made a lot of money, and that's where they stayed. And then they started porting their stuff to Android so they could make even more money. So understand that the people that flocked over to Objective-C, this wasn't out of some newfound love for Apple, other than the fact that Apple was going to give them money. All right? This was, they like money. Swift, though, was not an upgrade for these guys. It was there for a different reason. So what I'm going to do is I'm going to take all this stuff, I'm going to shrink it down. That's not really what I wanted to happen, but let's just roll with it, I suppose. And I'm going to label this. And I've mentioned it out loud a couple times, but these are our native languages. Now, on the flip side, we have a whole nother side of technology over here known as the web languages. All right, let me shrink these guys down because they're gonna be problematic pretty soon. All right, call that good. All right, so now again, even with our web languages today, they all came from C. So this is again supporting this idea of C being the great-great-grandparent or whatever of all of our modern languages. So if we can understand that core, that core language of C, any of these languages can be learned very quickly. All right. So, and I'm going to pick and choose because those of you who maybe have done anything in the web programming world realize there's a new flavor every single day almost in the web world. So when I say web world, what I'm talking about is technologies that are delivering our user interfaces that we see on our web pages, as well as the server side technology. So let me talk about that just for here, so I don't forget. First language I'm going to reference here is a language called Perl. We'll get back to that in a minute. And people are still hiring for this, by the way. And that's a language that's been around longer than the internet. In fact, I think if you saw, I posted a couple of summer internships on Slack yesterday under the general tab. So again, motivation for looking at Slack. Usually when we post internships up there, it's from a former student where we have some in with them. So if you apply for those, let me know and I can pass your resume on and kind of maybe get you onto the stack or something like that, unless I think you're an idiot. And then I don't know, we might have to talk dollars or something like that, I suppose. So when we, what was I talking about? Oh, bribes. That's right. No. What was I really talking about? Yeah, went from Perl. Oh, server, web tech. So when we talk about web tech, we have something called client side, and we have something called server side. All right. And let me draw a quick picture of how this works so we can connect some dots for us, because this is something that exists even on the native side of things. We just don't necessarily think about it as being the same. So historically, we have this concept of client-server programming. So we have our client, we have our server, and these guys talk to each other. All right, the client makes requests to the server responds to those requests and sends stuff back to the client. And the reason why we like this model is because oftentimes we have multiple clients all talking to a single server. So, for example, Google has a web server, right? And we have how many different clients are connecting to Google every second? A lot, right? A lot. Okay, so that means your web browser and your web browser and your web browser and your web browser are all connecting to this one server, and this one server is actually like a front man for about a big old server farm of probably 1,500 computers or something. But punchline is to this one web server to handle the requests of all those clients. All right, so that's the client-server model as opposed to having one server per client. But when we talk about the client-server model, so if we look at this in the web world, this is our browser. So Chrome or Internet Explorer. Well, it's not Internet Explorer now; it's Edge, right? Or Firefox, whatever. Pick your poison. Safari. So that's your web browser. The server is your web server. Web servers are popular ones today. They come in two flavors. We have, well, yeah, really, it's two flavors. We have Apache and we have IIS. All right, again, this is right tool for the job. I'm going to just, you can make an argument over which is better, but these, let's just call them equivalent. IIS is Internet Information Server. So if your server is running the Windows operating system, you're running IIS. Even though Apache exists for Windows, you're running IIS. Okay, that's the Microsoft web server that knows how to talk to Windows and knows how to talk to all the Microsofty stuff. So, IIS is the Windows web server. Apache is the everybody else web server. All right. So most servers on the internet, although I think it's becoming significantly closer to 50-50, but I think still a majority of web servers on the internet are running the Linux operating system or Unix. All the rest are running Windows. So let's just, since this isn't really important material for this class, this is more background material for us. I'm not going to ever ask you something about Apache versus IIS. This is context for us, okay? Let's just say that half the internet is running off of Apache, half the internet is running off of IIS. Regardless, both of these guys are speaking one language. They're speaking a language called HTTP. Okay? Hypertext Transport Protocol. That's the language of the internet. All right? So when a web browser makes a request to a web server, that request, they're not speaking English, they're not speaking German, they're speaking HTTP. All right? When the server spits it back, they're spitting it back in a language that the web browser knows, which is in an HTTP packet, but web browsers understand something called HTML. All right, so at the end of the day, well, I'm going to say HTML/JavaScript. Okay, so at the end of the day, no matter what this web browser asks for, what's getting spit back to it is something in the form of HTML and JavaScript. And then it shows up on our screen as pretty pictures and stuff. All right, so that's how the communication on the internet works. So we have some technologies that are all about how do we make stuff on the browser more modern? How do we make, sports scores and things like that update in real time without the entire page reloading, that kind of stuff. So technologies that are based on the client side. So this is our client side. Sometimes this is referred to as front end. Okay, so if you see a job description for client-side programmer or front-end developer, this is typically what they're talking about. Those are typically married to the web world, those phrases. They don't have to be, but they typically are. And they're talking about your audience is the web browser, which by extension then would be the people looking at the web browser. All right? Then you have... That is really funny. That it doesn't copy very fast. Like I have to purposely pause for it to catch up. Dumb Macs. I'm probably like one of the most anti-Mac people who uses a Mac. All right, so the flip side is we have our server side stuff or our back end programming. Okay, so server side, this is we're writing stuff that runs on our web server here. Now this web server is, has a default thing built into it. That's that HTTP protocol. It gets a GET request, it sends HTML back. Now every now and then though, you're requesting pages that don't have a .html extension on it. All right, so sometimes you'll put in, you'll see things like index.html, but you might also say index.php, okay, or index.aspx, that kind of stuff. So that extension on the requested file is something called a mime type. Okay, and this existed way before the internet, so for instance, on your computers, if you have a file that has a .docx on it, what is that? It's a Word file. So when you double click on it, Windows goes in, well, Windows or the Mac, since Word's on both, it goes and looks up the mime type for .docx and says, oh, this is Word. I'm going to go ahead and open up Word for you. When it doesn't recognize that extension, what does it do? It brings up that little pop-up and says open with, gives you the list of some of the applications it thinks you might need. That kind of thing. Okay, so it's just the generic term for this in computing is called the mime type. It's just a mapping between extensions and what applications they're associated with. All right. Again, I won't test you on stuff like that, but this is all trivia knowledge stuff that at some point you want to have there, because this is historically where we got to where we are today. But the concept of a mime type is important. The concept of this extension has meaning. So when this browser requests a page called index.html, the web server knows, oh, I don't have to do anything special. H.html is part of the HTTP protocol, so I can just go and look up the file and spit it back to you. No harm, no foul. But if you ask me for a PHP file, now I know that's a little bit above my pay grade. I know I'm the middleman. I know you're requesting it from me, but I'm going to go and get that file. So it's a text file that has, presumably PHP programming code in it, and I have to send it to somebody else. So I'll send it to the PHP module that's installed on Apache or IIS for it to get pre-processed. So it gets compiled or run or whatever, and the output of that program will be HTML. All right, so the web server is going to say, here's the PHP file, run it for me, give me the HTML back, and then I'll send the HTML and JavaScript back over to the browser. So I'm sending the results of this program running. That makes sense? Similarly, ASPX, that guy is the .NET, it's ASP.NET. Application server pages, which is Microsoft's competitor with PHP. So chances are, if you're requesting a PHP file, probably talking to Apache server. If you're requesting an ASPX file, it's actually not 100%, but let's call it 99.5% chance you're talking to a Windows server, Internet Information Server. All right, and this guy will pass it on to the .NET component architecture, which will run the ASP.NET program. It will spit back HTML and JavaScript, which the server will then pass over to the client. And the client will show it on the screen. Okay, so no matter what this browser asks for, he's going to get back HTML and JavaScript because that's what he knows how to put on the screen. He knows that's the pretty pictures and stuff he knows how to put on the screen. That makes sense? Do you understand this relationship between the client and the server? The stuff that's happening? Okay. So when we deal with our web technologies, and right now I'm focusing on web technologies, but you can really make connections with our native stuff with this too. Okay, but I've kind of abstracted our client server model down to browser web server. Okay, it's an example of the client server model. So when I talk about our web technologies in here, we're going to look at Perl. And I'm going to go through these significantly more quickly, so we'll definitely finish this next class. Perl, PHP, Ruby, Python, and then I'm going to say Node.js. And I'm just going to kind of float out here JavaScript, because JavaScript kind of, floats along the side of all these guys. All right. Because what I can do underneath JavaScript here is I'll just kind of hover it out here to the right. We can say Ajax. We can say jQuery. We can say Angular. We can say React. Now, how many of you have heard of at least one of these? All right, so this kind of goes back to this whole demystifying thing. Ajax, jQuery, Angular, React, all of these technologies are all about better ways of making certain aspects of our web pages update in real time without having the whole page to reload. The way it used to work with the internet in the early days, if you were trying to get the latest Packer score, you had to keep hitting refresh. So the page would ask the server for the updated score, it would bring the whole page back and re-display the page. Okay. Each of these technologies are how can we make our pages feel more lively without them constantly refreshing. Every single one of these guys are just JavaScript libraries. 100% of them. So they're this guy. They just have fancy schmancy names that mean something simple. All right. So what we're going to do next time is we're going to compare web tech. That's going to be our Perl versus PHP versus Ruby versus Python versus Node.js in the context of the client-server model, and then we'll start getting into variables for our programming stuff. Sound good? All right. I think you guys have already started the variable section in the book, right? So let's just pause that so we don't get ahead in the book. So take the next couple days off. Let's finish this and let's get into the programming stuff. Sound good? All right. I will see everybody on Friday.